just to brief us again on what we do at DSN. So like you all know, we have the commitment to raise 1 million AI talents and build AI solutions that will improve the quality of life and well-being of 2 billion people in emerging markets. I move straight to my next slide. So this is our evolution from 2010 to 2021. In fact, this is 2022. We just released our annual report. I'm very sure most of us would have seen it on our social media channel. So this is how we've been evolving over the years from being a learning and community. We'll do research and social good applications. We'll do corporate support and solution deployment. And we invest in startup also. So this is the award that we won, the Matter Impact Award at Deep Learning Data. This was in 2019. And this is another award that we won during the lockdown. So like I said, I'm just going to be giving a brief. This is our founder at one of the top AI conference. And then this is our annual report 2021. So we just released this. I'm very sure most of us would have seen this on our social media pages. My colleagues will be dropping the links to download this annual report. So if you would like to see the things that we've been doing for the past year, so you can use the link to download the annual report and see what we've been up to. Okay, so this is the DSN Beginners Python and Artificial Intelligence AI book for kids and teens. The book is simplified to the extent that even a 5-year-old kid can read and then understand what is Python programming. So my colleagues will be dropping all the important links in the chat room. And then this is our AI hub at number 33 Queen Street, Java. So you can always come around to see us there. Our hub is always open from 9 a.m. to 4 p.m. So this is so we are not alone at DSN. We have board of directors that actually give us advice, helps us to be on the right path, to do the right thing at every time. So this is the list of our board of directors. Yes, so finally, it's time to meet our speaker. I'm very sure all of us are excited to be in this session right now. And we are ready to learn acts. Yeah, so I will call it acts. We are ready to learn acts to actually build predictive models. So I'm just going to be doing a brief about Mr. Nasiruddin Rahim, while he's also going to talk about himself, and then we can do a deep dive for why we're here today. So Nasiruddin is a data scientist who has worked as a data science intern at Axamansa, Nigeria. He's also his India ambassador. So he's a final year of the Polytechnic Ibadan. He has won a couple of machine learning hackathons. So in 2022, he was able to claim the first position in 2 different hackathons and won second place in one hackathon, one of the 2 hackathons. Mr. Nasiruddin Rahim is a data scientist, and today is going to be giving us a deep dive on how he actually won the hackathon, and also how we can also practice by ourselves to win this type of hackathons. Ladies and gentlemen, please kindly help me welcome Mr. Nasiruddin in the chat room. Mr. Nasiruddin, can you hear me? Please confirm if you can hear me.
Yeah, good afternoon.
Good afternoon. Thank you for joining us. Yes, we can hear you. So I will stop sharing my screen now so that you'll be able to share your screen.
Good afternoon, everyone. Can you all see my screen?
Yes, your screen is up.
Yeah, thank you. Yeah, good afternoon, everyone. I greet each and every one of us present here. My name is Rahim Nasiruddin. Yeah, I will be here for the AI mentorship section at Data Science Networks, which is formerly known as Data Science Nigeria. And then I would love to say I'm one of the products and one of the person that attended the 2019 bootcamp. And since then, I've been able to do a lot of things in data science ecosystem. Thank you, Data Science Nigeria. So yeah, we'll be diving into our today's main section, which is all about AI Tunisia winning approach. This one was done from August 28th, and then we were able to receive the final leaderboard August 31st, which I claimed the first position. So I'll be talking about that today. Yeah, about me, my name is like as he said, my name is Rahim Nasruddin Adelaye. I'm a data scientist, and I've won 30 data science hackathon in 2020, whereby I'm able to claim first position in 2 of them, and the third one I'm able to claim the second position. Like the likes of one is on Maduro Hacks, the other one was on Cindy Africa, and the other one is on DeFi. And I've won a couple of machine learning hackathon over years since I started. So, and you can, this is my Twitter account. Yeah, before I get started into the introduction, I'm able to claim the first position in both my public and private leaderboard during the hackathon period, whereby we have 171 people enrolled for hackathon, and then we have just 53 people that are active during the hackathon. Then as we can see, I think I'm the only one I did not even jump here, and from the top 5 I had the lesser submissions among other participants, which we can all see. Yeah, so let me just make little things about the grocery store product forecasting challenge. What is it all about is for us to, can you forecast the number of products sold per store per week for a local grocery store? The data, we can see the category, it's focused on being intermediate. You're trying to help customer service, retail, and forecasting. So the links to the hackathon can be found on CD Africa, which I have the links here in my slide. So not to waste our time, this challenge is mainly a forecasting challenge, and there are various ways that we can try to approach a forecasting challenge, and which our data sets might be able to tell us what too little approach to be able to do in when you wanted to solve a problem. Because most times in data science ecosystem over years, we see that solving a forecasting challenge have different approach. In the likes of you trying to solve a forecasting challenge, use statistical approach. Like we all know the likes of, if you study statistics here, we have done some statistical course on time series, the likes of autoregressive moving average, the likes of semi-autoregressive moving average, and we have the likes of the one that is very common now, this is FB Prophet, whereby we try to solve univariate time series problem. But fortunately enough, this problem was not being addressed to just be a normal univariate time series problem. It's more of multivariate time series problem, whereby you can try to approach it in the regression approach, and you're going to have accurate predictions over the weeks you wanted to predict for. And the evaluation metrics for this challenge is root mean squared error, which is where this is what part of the evaluation metrics we can use to measure a predictive modeling in machine learning. And if you have the lower score, the better. So these are my methodologies in solving the problem. The most important is when we wanted from data set, we have different data set from different sources, whereby it's very necessary and then for us to be able to combine those data sets for you to be able to be a good machine learning model. As you all know that mostly trying to have data, you shouldn't have your data set in one places. So same as this hackathon, it does not come from one place, it comes from different sources, whereby you should be able to find a better way, the primary key in order for you to join data set. And the second approach I follow more is feature engineering. Then whereby trying to create new features, or if you already find enough that you have already found the features there that is already engineered, then it's part of feature engineering. And the third one is feature transformation. You're trying to see if there are some features that their data type, maybe mostly is either you are dealing with object data type, whereby they are categorical in nature, whereby you need to convert them to a numerical data in order for your machine learning model to understand what you wanted to be and for you to have accurate predictions. And the first step is me trying to use a machine learning model. And the final one, which is part of the thing that actually made me to imagine, was trying to process my predictions. And then, so let's move up through these steps one by one. So I just try to find a way to combine the data set in one way whereby I'm going to explain, because we are going to have the demo section later in this presentation too. So from the original data set, we have our train and test data, whereby we know the training data is always consists of the target variable, because the target variable is named target variable, and the test data is the target variable. And those are the features we have. The external features we have, the likes of dates, holiday, store, because we also have them. And then one of the most important thing is to be able to find a unique identifier for you to match those tables, in order for you to have a table that is meaningful and that is going to be useful for the business or for the problem you are trying to solve. Now we have our train and test data, and then we need the date features, because they tell us we are solving a forecasting challenge. And then one of the major important thing doing for solving a multivariate forecasting challenge is when you have a date features, trying to capture some features from temporary features like the days, number of weeks, is it quarter time, is it month end, is it new end? And this was able to be combined by using the date as the primary key. They combined both the train and test and the date, because trying to check the data, we found out that trying to have this kind of schema is something we should do, and we can merge it only on date. And before moving to the store ID, we also have the holiday features, whereby the location of that particular stores, the holiday is already there. And then one of the major important thing, and one of the features that has and building a lot of machine learning models, especially in forecast, is trying to identify if there will be holiday or not. And I'm able to combine the holiday data set just to pick if there is holiday maybe present in the train or test data, or if there will not be not. And I generated this is holiday features. Then I had to join the store data set too, in order to capture some information too, trying to use the store ID. And then I have to combine my is holiday with the various features I'm combining here, in order for me to have my final training and test data, for me to a good machine. One of the major things that happen in the hackathon is just that the data sets, the train and test, and the submission file are not with the same shapes. And for you to have a score predictions on Cindy leaderboard, you have to find a better way to make sure that you're equal, based on maybe trying to use the ID. Let me move to the next slide. In the data set that we have this is about the features, we have the times. I found out that the store ID is in the string format, whereby it says store 1, store 2, store 3, or category 4, category 21, category 32. So one of the major things to do in data science is for it to find something like this, you can either do encoding, maybe one-hot encoding, or label encoding, in order to convert the categorical features. I didn't do that. What I have to find, I think maybe those people trying to organize data sets actually like they should do it this way. And I thought, fine. Store ID is just really trying to assign number to a particular store. So this might be store 1, store 2, store 3. Since I have the variable name already, so I don't have the numbers in order for me to be a good predictive model. A machine learning model is mean trying, because when you want it to be the machine learning model, you try to train your model on your training data, because from your training data, then you try to generate the prediction for the test data. So in order for you to have accurate prediction, so I have to train my data using the LightGBM regressor. The major importance of using LightGBM regressor is that we are going to check the rules of the data sheet. The training data is above 2 million. The data set is very huge. And over years, since LightGBM has been developed by Microsoft, is very fast, accurate, and then over years, it has been a good competitive machine learning models competing with XGBoost, mainly in various machine learning hackathons across Zindi, Kaggle, different machine learning hackathon. And the major reason why I actually use that the data set is very that my system does not have that much memory to use XGBoost, so I have to follow LightGBM. And one of the major thing parameters too, because we all have the same parameters initially in LightGBM regressor, so we have the same objective, which is default for everyone. And one of the major things that has helped in winning a lot of hackathons is you trying to train your parameters in order to fill the data well into the model and to generate accurate predictions. Then after that, I have to use 5K fold cross-validation, whereby I'm not just trying to split my data into train and test data, which is usually called one-hot cross-validation. What I did is just that me trying to make sure those predictions are divided into 5 samples. Then the latter have to just make the average of this prediction, and why the evaluation matrix is a root mean squared error. And after trying to generate my predictions on the test data, I had to pre-process the predictions. Then it was stated from the initial accounting that we have to convert our final prediction into, we have also have a good model, which is advisable for you to follow, because people that organize data sets has already advised us to do so. So those are the things. Talk is cheap. Let's demo now. We are available because we have to come back to this section whereby we are going to have a lot of maybe question and answer, or trying to talk in general view of machine learning hackathon and how I come to this. And this I have the notebook link with me. Is there a way for me to copy this? Can I copy this? Yeah. So I have the notebook section with me here. On my GitHub repository, this is the link. Now we are moving to the practical aspects of the solution, and then yeah. So yeah, this is the notebook we are going to be using solving a problem. We are going to see how the data set is being formatted. I don't want it to be more of too technical. So I've already have the code, and I'll just work and ask, then I'll be able to explain better. So the executive summary of all what I've done in this notebook is not serious or something that is too large for people to grab, or the code is not that dirty, it's not that too clumsy. And the funniest enough, I didn't use any assembly method in trying to claim the first position. And when I was talking with the people, with the person that reviewed this code, he said I part of the top solution. I'm one of the people that have the perfect code that is very easy to run, easy to workflow and all that stuff. You can also check that with me. So the executive summary is me trying to use a LightGBM regression model, which by optimize the objective with 3D regression to undo the spike at 0, and post-process my prediction of text data, and which is being aggregated into summation because we wanted to actually know the total summation. And the various features we use is the train, the test, the dates, the store ID, and all the date features, which I've shown in the previous slide. And our train and test data are joined with dates and store ID, which I will show. And there are some features that is being drawn because we have the features in the training data, and when I check the test data, the features is not there, and I have to drop it. And the model is built using LightGBM with 5 preprocessing cross-validations, and the precision text is aggregated across various ID. In order for me to have it, because when I have my test predictions, I have to make sure it's going to have the same shape, the same format with the sample submission file where to be used on Cindy leaderboard for my scoring. And I have to take the natural log to transform my final prediction. So these are the things that work for me. These are the things that does not work. So these are the various versions of on my system as it stands now to run the. You might try different versions. You might not actually get the same score, but it might be better or just little different. But I'm still sure it still has to be the top solution for now as it stands. So import the necessary libraries. Sorry, because most time people that do quantitative data science, we already have some libraries we loaded. We try to do that because in quantitative data science and even data science, you have to good at experimenting a lot. You have to be able to try different things and see what works before you start trying to optimize your solutions. So yeah, if I run the code there, it should run faster. And then let me run this. So we have various data sets because it was not being stated to me to go to trying to download data set because of the time frame and for us to be able to focus mostly on building the solutions. So we have different data. So we have the training data, the test data, the stored data, the holiday data, the date data, and the sample submission file. So I think I have to run this twice because of me trying to agree some things later. So the first thing is just for me to try to check the shape of the data set, because you can't assume that you have the same data with the, most times our training data are always more than our test data. But the sample submission file, the test data and sample submission file, are they always equal? Not at all. So you have to make sure you are checking the shape of your data. Apart from that, too, various data sets we have, it's not just train and test here. You have the stores, you have the holidays, you have the dates. You have to try to check the them and see the calculations that work with the train and test. How can you try to mesh those tables together and able to have a good table? You can't start building model with different. The beauty of machine learning is still trying to combine different. So, and then when I was extensive, we see that in our training data is very large, which is above 2 million. But most times you understand that our training data and test data are only different by one features alone, which is the target features. The training data will be the target features, while the test data is the target feature. Most times when our training data is 6, our and our text data is just 4. So now we have to, after checking this, the store shape we have 54, the holiday we have 21. We have, so this means that in the holiday we just have 21 days across years with holiday, because sometimes this year there might be a particular day in a day, there might not be a particular day in a day, and we have various dates features and we found out that our sample submission file is 14,000, while our test submission file is 99,000. So now let's look at the head of our training data. It was found that we have different dates, which is being combined. We have the store ID, the categorical ID, the category ID, our target ID, on promotion, and number of transactions. I want to hello.
Hello,
Hi.
we can hear you now.
Yes,
I
we
think we
can hear
lost
you
you
On
for
our
now.
some
date data,
seconds.
we found in it because it is stated a day of week. Can you hear me now? Network in break.
Hello, can you hear us?
Yes, I can hear.
Okay.
Yeah, I can hear
So I
you.
think
I can hear you.
he's
All
having
right.
issues with
Thank you
the
so much.
network. The network has been bad all day. Mr. Ryan, can you hear us now?
I can hear you very well.
Okay, so I think better. Yeah, so we can continue.
So where did I stop? Sorry, I don't know why this network is doing like this.
You can just continue from here.
Continue from that place where you were trying to say the train dataset.head.
Okay. Thank you so much. Sorry. Please let me know if there is you can let me know if there is any if you can't hear me. So here now I'm trying to check the training data help in order for me to see the shapes visually. So I'm just seeing the first 5 rows. And the second part, I have to check my text data. So I found out that we are missing the target and the number of transactions. Missing the target is a normal thing in a machine learning hackathon. Most times it tests the train data with the target variable and the test data is without the target variable. So I have to check my dates table now, whereby, like I said initially, when we have a univariate time series, let's say we're having a code like September 15, 2022, there are a lot of features we can generate. Temporary features like year, the month, the day of the month, the day of the week, the day of the year. All these features are temporary time series features generated, most especially when you wanted to approach your time series problem in a regression way. So we do generate this type of features most times. And one of the things that actually, so we can see we have something here, which is year of the week here. So it is mostly that the week of the year, which is 1, is being added by 100 in order for us to have our IDs going to the show. So we also see that we have the holiday features, we have the dates, where the holiday occurs, and we have the type. And we also have the style ID, which include the city, because most of this data, to me, it has been anonymized. So you can't actually know the city they are trying to talk about because it's part of you trying to give your data privacy, especially if you have maybe a large store for your computers not to know what you are doing. So you have the city, we have the type, we have these clusters of this store ID. And we can see now we have our the sample submission file. Now, for us to submit something on our machine learning model, we have to make sure we have a good structure in order for us to have the sample submission file, in order for us to have a text file, text data, or to have the text ID that will look exactly as what the sample submission file is giving us. Because as time goes on, we want to optimize our model, or we wanted to improve things on our model. We should have that in our pipeline already without trying to do it over time. And I think most times, most people that actually wanted to complete this, most of them stuck here. Like they have already built their machine learning model, see their questions, but they can't submit their predictions on Cindy leaderboard for scoring. Before I go to that, I want us to understand something in predictive modeling. Our target features is always continuous in nature. It's always continuous. Maybe trying to have something like price, price cannot be maybe 1, 2, 3. It's not classified, it's a regression problem. And then I showed something here. Most times when we try to build a regression problem, we're always trying to find the outliers in our target features. If you, okay, fine, I want to deal with these outliers. Am I going to do transformation? Maybe it's log transformation, maybe it's SQL transformation, or you are trying to use Boy's clause transformation, or different form of transformation. Now looking at our raw target distribution, we observe that our raw target distribution, this graph is not, because in this notebook I don't have much a lot of exploratory data analysis. It's not much here. Like I just have to show this because I think this is the most important thing for you, because problems are not to be solved in one way, so you have to look in a different way. The first, our raw target features, we have a lot of spike at 0. I try to do the log transformation. I still see like I think we still have, it's still skewed. Trying to do SQLT is still skewed. Like this is a problem. And I found out that trying to do the normal statistics, the mean of the distribution is closer to 400, and the maximum features is 124,000. Fine. And the minimum is 0.0. The 25 percentile, the 25% of the total data set of our target features are 0, and which is confirmed here that we've observed that most of the target as maybe that day they didn't make any sales or it's 0. So 26.5% of target are 0.0. Now, let's move to the way to treat our test and sample submission file. The first thing to be done is we already know that we found that here the dates are unique in both train and test. So we have to join it by date for train and test data. And our sample submission files, look, are you trying to aggregate a lot of features? This shows that the aggregate year of week, year, comma, week, the aggregate and the category ID is being aggregated. That means that for us to have a good perfect target, we have to aggregate essentially 3 things that are different, and one is that which is year, comma, week. So if you have year, comma, week that is not correct, you might not actually to make submission on Cindy leaderboard. So now, I just have to create a new variable UIW for train and test, trying to use the year, comma, week, which can be done more in a more optimized way. Now, I have the ID that looks exactly as my sample submission file. I have to generate it, whereby I'm going to have the year underscore week, trying to make the difference by underscore the slash call of what. Then I'm trying to, because the year of the week data types is numeric, so I have to convert it to string. The store ID is already object data, and the category is also object data. So I've done that for the train. It's not necessary for the train, but I actually do that in order for me to know where I'm starting from if there is any bug in my code. So I generate from test data too. We can just try to check this though. If we check now, I'm going to the test data, text.ed. We can see now we have the ID here, and if I check my sub.ed, they look the same right now. So I think I've achieved the first aim of how to build a good machine learning problem, because now I know that when I have my predictions, there are little things for me to do. The little things will be discussed later as we are going. And then, so now, before I start managing the stored data set, I observed that we have some unique holiday dates, and which can be found in the train dates data. So I had to generate the holiday features from both my train and test, trying to find if there is a date that's that they are identical in the train data, it should make it okay, this is true. And if not, false. Same for the test data too. I have to generate that features, which is mostly 0 and 1. It's not, but it's going to be a Boolean factor. And the next thing I did is trying to match the stored data set, like I showed previously on the Google slide. So now I'm trying to match the store ID features. So let me run this too. It's going to, so trying to match the store ID. If we able to look at our train data, we can see we have new features. So we are the store ID is already there. The shape is now 26. Fine. Now, like I said earlier in the previous slide, the store ID is not transformed using label encoding, or though I tried one of the encoding, and when I check with my prediction, it does not work better because in machine learning, no failure theorem. So some approach might be better, but it's not the best for everyone. And most importantly, we should take note of something which I'll discuss later. When we are trying to approach a machine learning problem, that this you want to use a gradient boosted model like LightGBM, it is most times you trying to have label encoding or trying to have ordinary encoding works fine better than using one of the encoding most times, but sometimes one of the coding also does better, but it is allowed and it is advisable to try them and see the one that works better. Then we start optimizing our model across the pipeline we are using. Now, I'm able to transform the, trying to delete the store ID and trying to just select the numerical one, the store ID 1, maybe it's 1, 2, or category 24, 36, and it was converted to integer. Yeah. So now, before going to this, now we are going to our machine learning model. Our machine learning model now is just that in order, because the data set is very large, so I have to make sure I'm doing things step by step. I had to drop the YW, which I guess is just a redundancy, the train ID, because most times in quantitative data science, the ID is not to be used. Some competitive data, some competition will tell you that using the ID to generate predictions will not be allowed. We can call it most times that we call something, it might cause leakages, or it's not advised because it's just it might be a random assigned numbers in order to identify one or two things. And we also have our test features, whereby we found that the number of transactions is not found in the test data. So in our training data, I had to drop just 3 columns, and our test data I just have to drop just 2 alone. Let me check the chart section before moving. Wow, people, please, can you hear me? Should I move on?
Yes, you can hear Mr. Ryan. So we have a dedicated time for Q&A, so you can move on. Yeah, we have a dedicated time for Q&A. So if you have any question, everyone, just note them down. We are going to be taking Q&A after this session. Yeah, so you can continue. Thank you so much.
Yeah, so now I want to build a machine learning model. We already know the normal statistical model. You're trying to have your dependent and independent features. So as a statistician, we do call this one explanatory variable of y, which is the response. Our target is our response. It is essential not to have our response variable in our explanatory variable. So we normally use x and y. It's very common. And then if you have done one or little projects, that's what we call it. And then now you have to move to our hyperparameters training. Yeah. One of the most things to note here is just that I have a lot of hyperparameters here, and some of them optimize over time. I have to make that daily submission. Let me just be sincere. I have to reach up to 20 submissions before I start having a good model that score less than 1. If I'm not, yes, I have to have that, because at the beginning it was not that easy. I have to start optimizing, trying to see what to do. This not to just look finer. There I have a lot of rough sheets, because it's not, you just have to keep on seeing the best thing before you start optimizing. Yeah, I have the objective here, which is called 3D. The metric is RMSE. My learning rate is 0.01. The sub features, the sub rows, we can check LightGBM documentation in order to understand some of the metrics where I've mentioned subs. The lambda L2 is for us to regularize our model. The verbosity is just for us to have something faster. The number of iteration is how your model is going to move in across the learning rates. And the number of leaves is the type of how the leaves will be generated. And the mean data in leaves is for us to be able to regularize the number of leaves. So yeah, this is where I constructed my this. If I run this, it might take a lot of time. It might take up to 30 minutes. So I won't want to run this, because LightGBM model is fast. My model is, they don't have to do that good eye processor, and the secondly is going to take our time. So again, I have the part of my K-food here, which is something that, like I said earlier, in computer data science, you already have some things you use. It's not like every time you start building things. You already have things you use. You already have things you can look up to and try to incorporate into yours. What makes different most times is how you gather your data, the features you use your hyperparameters tuning most times, and our cross-validation tools also helps. But mostly times using 5K fold if it's a regression problem, or stratify K fold is a classification problem, or most times two works better. So the data is being split here, which is shuffled by random state one. So we can generate different predictions trying to have different random states. We should take note of that, which will be discussed later. And then we split the S and train, and here we try to make the predictions. And I use the mean squared error. When it's false, that is root mean squared error, unlike the np.sqrt we normally used. And this is to make the prediction on the test dates, and as it's going over wide, trying to iterate 5 times. This one is the average predictions is being appended. The prediction is being appended into this. So across my evaluation metrics, you have the training error, we have the evaluation error. So I try to log this. We should note of this. The local CV I'm having here does not correlate with my leaderboard score, which is something that is still need for us to maybe to do some data augmentation. But one of the major things I've found in this year is that as my local CV is reducing from what I set up, once I submit it to my leaderboard, then the RMC also decreases. And one of the major reasons why I have lesser submission on the leaderboard. Now, it's just for me to check the feature importance and see what the features that work well. This might also help us in the long run trying to find some features. Maybe the model you are building is already overfitting. Because adding being this one just add the letter weight, and all the other one have letter weight. You should check your model. The store ID, the categorical ID, the date of year. Those are the important features we have as a stand. Yeah, I'm trying to check the mean of my predictions. Lest I forget, it was stated that our train and test and our sample submission file are not with the same words, with the same size. We can see that after trying to make my prediction on the test data, I have 99,000. And then what I found is that the ID that is in my test data, let's say test ID. This is the ID. If you check the value underscore kinds, 77, right? Let me, I have to check the number of unique. Is this? So we found out that our test ID have already aggregate the same thing as the sample submission file we have, because our length of our sample submission file is what? Is the same thing. So that's when that after having our prediction over time with 99,000, then we have to make sure we aggregate it based on the ID on the text data in order for us to have the same format and shape for the for our prediction to be submitted on the Cindy leaderboard score. So yeah, I actually have to take the average of all my predictions across the 5K fold. Then this one now trying to just select the text ID and the target ID, calling it sub, and these are my targets based on various ID. So I have to aggregate the predictions across each ID by their total. So yeah, I'm able to aggregate it by ID across the target to the sub. Then I'm able to have a prediction that I can submit to the Cindy leaderboard. Let me just start running, because maybe later I'm able to demonstrate this, because I can't show the so but it's going to take a longer time. So yeah, these are the little things I do for us to show. So these are the reference that actually helped me in winning the hackathon. There's a particular playlist in data science community. We all know that we are allowed, and one of the most important things I love about being a community data science over years is that I love what the community does. You give credit to whom credit used to be. You don't take someone else code or anything without trying to give credit. Okay, this this thing I achieved is not just by my alone. I actually had to do this. And this is a YouTube series on approaching time series problem, which is being organized by Abhishek Thakur, which is the first quadruple grandmaster, and Conrad, which is a time series guru. And this is, he has the series to 9 now, and this is the 4th one, which really helped me. And I show appreciation to them. So lest I forgot, before we move back to the slide, the major thing that actually helped me in this hackathon is just that this objective, by default, our LightGBM regressor parameter is going to be in regression. We have regression, we have Python, we have regression, we have Python, we have Sweden. And it is noted when you are trying to deal with a forecasting problem and you have spike at 0, it is better you try to optimize using Sweden or trying to use Python, because I actually used Python before, which gave me 0.72. Then when I moved to 3D, at first instance, it moved to 0.37. We can see the lot difference. And if you try to check various documentations about trying to have something like spike at 0, trying to optimize it, the better objective to use 3D. I don't know, because I'm not saying that, but most people trying to use just the normal objective function for regression, and which is going to just take the spike at 0, maybe trying to use it to be normal distribution, which is not going to be able to understand our target features very well. And which is, I would say this is the most important thing that actually give me a good start in order to win the hackathon, and the various things like learning rates and the number of iterations without trying to see maybe the model. The data will learn more when you see a lot of iterations from the machine learning. So these are the little practical section I have. So before I go back to the slide, my appreciation to Abhishek Thakur and Conrad, and then you can see that I don't have a lot of data variation notebook. Yes, it's sometimes you just have to see the way, and this is a forecasting problem, and then I just need to find the optimized model. Thank you. Moving back to the slide after the practical section. So let me just summarize what worked for me. So like I said earlier, I merged the tables to have more features, using the proper encoding techniques for store and categorical ID, using LightGBM model with 5K fold cross validation, treating the regression model objective with 3D, post-processing the prediction by summing across ID on the test data. These are the things that work for me. What did not work? I used one-hot encoding for the category features. I aggregate some features. Yes, as a complete data science guy, I actually want to add the number of transactions in my test data. So I had to combine it with store ID, categorical ID, find the average, then take it to the test data. When I did it, it doesn't work for me. So a lot of things done, trying to aggregate a lot of features, it does not work. I have to drop back the features, because sometimes feature engineering is not about you trying to create a lot of features. No. Sometimes you need the features already have, you need to work with them well, even trying to reduce them. From what I found about it, and using CardBoost model does not work for me. We all find I'm a fan of CardBoost model, but over time, from research, from CardGlass, from different hackathon, hardly you see people winning 10 machine learning hackathon, and you see CardBoost coming twice. You see that they use LightGBM or XGBoost. So, but CardBoost can do a good starter line. Maybe when you are trying to struggle with XGBoost and LightGBM, which I do most times. And when I say CardBoost can give me a prediction that, okay, fine, it has done better, then I will have to go back and check my LightGBM or XGBoost model. Okay, fine. I think if CardBoost can give me maybe accuracy, 90% accuracy, then this one, if I optimize them better, I can have like 3% accuracy. This was just for me to test, but it does not work for me yet. No slideshow, sorry. My recommendation is just that I will advise any of us to maybe because I can't call myself an expert yet. So a beginners, intermediate, or expert, if you love to do some project in data science, compete on Kaggle in the machine of all the 5. I found it to be very engaging. I found it to be one of the ways to have a good machine learning skills. And what I found over time is just that I will not be talking about most Kaggle grandmasters I've seen And most people that also in computer data scientists are also in industry doing fine. That's what I know about. That's what I've seen over years. So I'm not trying to say, okay, computer data science or data science. It's not a lot of data science, but it's part of it. And it's very essential. Trying to have good problem solving skills, trying to know the right metrics for the problem you want to solve. This also because most of the hackathon have been curated by people that know the business solution. So you trying to solve that kind of problem, you also have a lot of experience. And I also remember when hackathon just finished on Kaggle Amex, which is $100,000 US. Those people that won the competitions will be able to get interview with American Express. So it's not just about you trying to win, or you can have job interviews, you can be able to see a lot of job. And you can, it's also advisable to read various machine learning competitions winner solutions. I do on Kaggle, on Zindi, on Defy, on HackerX, on Driven Data, on a lot of computer data science, because I think I know up to like 10 or 11 of them. On machine app you can do, because it will also help you in trying to win solutions next time. And take time to read research paper when necessary. I think I've tried to approach some problems trying to do some research paper, which I found out that most Kaggle grandmasters too, they do say they do read research paper. So it's not about you trying to compete alone. If you really want to get a good score, sometimes you have to do research and you have to implement. Not just you have to implement your research, and it's advisable to experiment a lot during machine learning competitions. Make sure you play all the cards you have when you are competing. Once you have, maybe you have 10 things in line, maybe the base after the base that you try to iterate. Make sure you exhaust everything you know, because maybe it's the one that you are trying to overlook. It's going to be the one that will give you the good baseline that you start optimizing your model. And trying to have good cross-validation strategy and random seed. Sometimes random seed can just be the little things you need to win a machine learning hackathon. Imagine you have 0.34 and the other one has 0.31. Maybe it's the random that adds. And I would say if you follow Kaggle Grandmaster's YouTube channel for inspiration and try to test out like Abhishek Thakur, the Trita Data Science, whereby a lot of winner solutions shares their approach and all stuff. So these are the little references I have, which I showed in my notebook. My sincere appreciation to Abhishek Thakur, because I think I just have to show credit to them, because if their time series, YouTube series that really helped me, and the notebook they provided open source or Kaggle that really helped me. I'm a fan of Kaggle anyway. So thank you so much. I think we can have the question and answer section now.
Wow. Thank you so much, Mr. Rahim Nasiruddin. This is what I call a deep dive. Thank you so much for taking your time to share all this knowledge with us. Okay, yes, this is huge. Ibrahim said this is huge. Okay, so ladies and gentlemen, if you have any question, in the next few minutes, we are going to be taking up questions now. We are currently in the Q&A session. So if you have any question, just drop it in the chat room. We'll pick it up from there, and then Mr. Nasiruddin can answer your question. Okay, so we have the first question in the chat room for Zero Spike. Did you try class balancing?
Yeah, for the Zero Spike of a thing, I then try to balance the class. And then in trying to, if I try to say I want to balance the class of the problem, is for you to solve the problem in a way that you just find a way to solve the problem the easiest way. And the easiest way on that time, and the easiest way I learned and I checked, I made research on is trying to optimize, instead of trying to use LightGBM model to your objective regression, optimize it with Sweden objectives. So in order to capture the spike at zero, in order to solve the problem. Yeah.
Thank you so much. So we have another question from Olajide. So he's asking about the map function that you used. So he said he would like to know more about it. So I don't know if you can just quickly tell us a few things about the map function you use. So there's another question from him also. The metrics error. Come here, I'm trying to see.
I think he mentioned there log one log maybe log
Yes.
1p, yeah, natural log. So yeah, now, oh sorry, this map function here, like I said earlier in my slide, what I did is the purpose is that I want to remove the store underscore and just remain the one. So when I have the map ID here, I actually split it because what separates the store and one is the underscore below. So then if you separate, it's going to be index 0 and 1. So I have to pick the index 1, which the ones, the 24 falls in. So this is the map function using lambda function. And the log wall log.1p, like I showed earlier here, these are the various transformation techniques you can try to use. You trying to, maybe your target variable is either left or right skewed. You trying to make it in a normal distribution format. So that's what the logs 1p, trying to take the natural log and taking care of the zero. Because if you use natural, if you use the only log, if the log cannot take 0 and it's going to bring some error. So the long 1p is what it's advisable to use.
Thank you so much. So there's a question from Benedict. So he's asking if you used any stat-based model like SARMA or ARIMA. Okay.
Yeah. From using stat model, I did not even think of using it. And I don't know, but I'll be 80% or 90% sure that the ARIMA and the SARIMA might not be able to, because the ARIMA and SARIMA most times does well. Maybe you are trying to deal with univariate time series. So from what we found here, we are not trying to talk about the values and the values and the date alone. We have the values, we have the dates, we also have the store ID, we also have the holiday features. So the SARIMA, the ARIMA, the various statistical model can, to me, over years, they are not meant to be the LightGBM model. I did not try them at all. I just focus on the one that I'm sure is going to give me better prediction. And since we are not dealing with univariate time series, so multivariate time series, then I follow the regression approach.
Yeah. Thank you so much. Okay, so there is a question from Ismail. Okay, I think I'll be the appropriate person to answer. So he's asking about this slide. So this session is actually recorded, so you can always watch again on our DSN YouTube channel. My colleagues will be dropping the links to our DSN YouTube channel. So this session is recorded. You can always fall back on it at any time. So there's a question from David. I'm just going to be picking let's say 2 or 3 more questions, and then we can call it a day. So there's a question from David. When you did feature engineering from store ID and category ID, don't you think it introduces data leakage?
Yeah, introducing data leakage has to come with a thing. It is noted that most times when trying to host the competitions, the people organizing the competitions are also careful about data leakage. And the store ID and the category ID is that me trying to have that, me trying to capture the information from the trainer and test. And as you all know, you trying to be the machine learning project is not just one thing, it's something iterative. So causing data leakage, me trying to know the actual metadata or where they try actually, because data leakage most times either you try to have the data that really contributes a lot maybe to the values you are trying to measure. So personally, I don't check for that, and then I don't think it contributes to data leakage at its standard. So yes.
Thank you so much. So there's a question from Ernest asking about data science competition sites. So we have Kaggle, we have Zindi, we have a lot of them, Ernest. So you can always search to know more on the data science competition site that we have. Yeah, so there's a question from Gideon. He's asking if only CatBoost was what you tried before settling for LGBM regressor.
Yeah, the fact is just that all models no free lunch, like I said earlier. All models are good, but some are useful. It is noted over years that linear regression model, they always have less accuracy, but they are interpretable. We are here to win a machine learning hackathon. And over years, the gradient boosting model has done finds a lot. In terms of the data set, data intensive, like we have 2 million. I don't think in linear regression or the parameters of linear regression will be able to handle that. And I tried CatBoost because I felt like it's going to be fast, but it does not work. I didn't try XGBoost. XGBoost might work fine, but it's going to take a lot of time. I didn't try this because I just have to optimize. And then based on things, LightGBM regressor is not a bad for winning a machine learning hackathon or building a good generalized predictive modeling. Yes.
Thank you so much, Mr. Rahim Nasiruddin. Thank you for sharing all this knowledge with us. So my colleague has dropped the link to our DSN YouTube channel. Like I said, this session is recorded. If you missed at any point, you can always fall back on the videos. What you need to do is just to search, is just to click on this link and then it will take you to the DSN YouTube channel. So I have another question from Ismail. He's asking if avoiding multicollinearity is important from competitions.
From what I've done, I've checked, a lot of calculus masters have said, if you are using a extreme gradient boosting model, those assumptions is not necessary for you to check, because most times those models understand that multicollinearities happen and they just pick just one thing for them to do. Most time we have the likes of, I don't know the kind of percentage you are trying to set. Most time you do see a lot of features to degrade over maybe trying to have a particular ID, and you observe that maybe when you try to check the correlations or among those features, they are going to be like 95% correlation or maybe a positive or negative correlation, or you finding that they are 98%. And when you try to use the extreme gradient boosting model, because when we want to do machine learning composition, from what I found earlier is the three machine learning model champion, the two machine learning champion is LightGBM or XGBoost. It's something that cuts across everything. If you can check a lot of winning solutions, the kind of CatBoost random forest might come maybe trying to do some blending or trying to do some stacking or trying to do some assembly methods. So the LightGBM and XGBoost are the art. Unlike before, random forest is the art, but now either LightGBM or XGBoost. But if you want to assemble a lot of model, like what someone said earlier, you can try a lot of model. Even like I didn't try to use something around the long short-term memory, the LXCM model, trying to use the current neural network, RNN, or trying to use that. I just try to use a machine learning model. So to my own advice is just that if you are trying to use something like that, multicollinearity is good to check for it as a statistician, but having multicollinearity using the extreme gradient boosting model, if you check a future report and see that it's not affecting them, maybe the mostly the model is handling the multicollinearity for you. Yeah, that's it.
Thank you so much. This has been a wonderful session. So let me see who have another question on the chat room. Okay, so David is asking how long this competition took. I think it ran for a day. So Mr. Rahim, how long was this competition?
Yeah, this competition just took 20 hours.
Wow. Interesting.
20 hours, you just have to, because fortunately for me, I have to sleep over, because if I maybe say I want to sleep or go somewhere to relax, maybe I'm not going to emerge as the winner, because I have to start getting myself maybe 6 hours to the end of the hackathon. So it's just a long journey over that pretty long of time for me that day entirely. Yeah.
Wow, interesting. Yeah, thank you so much. Thank you, everyone. So I'll be sharing my screen in the next 1 second.
Yeah. Let me try to finish my slide. Sorry.
Okay.
Yeah,
you still have
my thank you to Data Science Nigeria for the opportunity. And like the co-founder, our that usually says, we want to build 1 million AI talent in 10 years. And I'm very happy to contribute my little quota to building a 1 million AI talent. And we know that with Data Science Nigeria, we have them on Twitter, Instagram, the Facebook, and the YouTube channel. And I want to use this opportunity to thank Brother David, which is the data science community, the Bukumi and other data science stars for giving me the opportunity to have a wonderful presentation, because it's something that's yeah, it's really, because but really have to call me and talk to me and give me some little tips. I'm really thankful for that. And
You are most
on the
welcome, sir.
all to all my viewers, and I think we should just try to find a way to most times, sometimes maybe we just try to play one or two hackathon. I'm very sure there is something to learn. That's just the reality. There is something to learn when you try to do competitive data science. Thank you. Yeah.
Thank you so much. This is fantastic. Thank you for honoring our invitation also to do this for us. Thank you so much. So I'll be sharing my screen, like I said. So I just want to talk about the next event that we're going to be having in the next few days. So tomorrow we are going to be hosting our DSN Twitter space. I'm very sure most of us would have participated in our recent Twitter space that we had. So another one will be happening tomorrow, 6 p.m. to 7 p.m. So we're going to be learning about careers and opportunities in data science. So we have our speakers listed out already. So let's meet again by 6 to 7 p.m. on Twitter. And then on Saturday, we'll have another packed event for you. Clustering algorithm and its business application. So Mr. Moshudiaya will be joining us. It's going to be a live session on Saturday from 5 to 6 p.m. also. So I hope to see you guys there. Thank you everyone for joining this session. Thank you so much, Mr. Nasiruddin. I think please can you share your social media details in the chat room if people would like to connect with you later on. You can just share your LinkedIn and Twitter handle so they can connect with you.
Let me share my. That's my Twitter account. I'm trying to let me.
Yeah.
Sorry, let me just get my LinkedIn.
So much. Thank you everyone for joining us.
Yeah, my LinkedIn is Brian.
Great.
Yeah. Thank you so much. Yeah, they can just search name. They will find it. Yeah.
All right. Thank you so much. Thank you everyone for joining us again this afternoon. Hope to see you on the DSN Twitter space and then on Saturday also for the DSN mentorship class. Do enjoy the rest of your day. Bye.
Thank you. Bye.
Thank you, guys. Really appreciate it.